Well, hi, good morning. Thank you for joining me in my shop here with me and my cats. We've got, who is it? Where'd he go? Only one cat now. There he is. So, thank you very much for joining me in my shop here. Today is May 29th. And hey, it's a new world today because if I understand it right, and maybe I don't, the whole tariff thing has been swept aside in the United States. Wow, what a different day. How about we do this? No, don't look in the light. Don't look. No, you can't go in there. You can't go in there. So you can see from the tube tester up on my bench that the plan today is to test the tubes in this radio, which I vigorously dusted yesterday. Let's take a look at it with the dust clear. I heard from the owner that his grandfather kept this radio in a room with a ping pong table, and that probably explains how a ping pong ball got into the back of the table. Man, this is a made in England ping pong ball. Who would have thought? England. Okay, so the tube tester I'm going to use is a very well-known tube tester here in this part of the world anyway, in Canada. It's quite a popular tube tester. Still around, quite a few of these floating around. I'm happy to have one. The 966, the Stark 9666. Very fast tube tester to operate, so and it's quick to set up and utilize. Okay, I don't think there's any particular order we should do these in, really. So I'm just going to do it by geography. We'll start at this end. We'll start at the input end of the radio, I guess. Why not? We'll start with this tube here. If I was smart, I'd have a way of verifying that these are the correct tubes. Trying to get this off without twisting it too much. And the reason is that you can pull the grid cap right off the tube. And I'm not sure this is any better what I'm doing here. It looks like these have been squeezed for additional spring power. Holy smokes. Come off there. There we go. Ooh, very, very stiff wire too. No. Okay. So much excitement testing a tube. 6K7. Okay. What we're going to do now, we're going to dial. I guess I got to plug this guy in here. 6K7. 6EFGHIJK. 6K7 right there. Set the filament voltage. Set the filament connections here. JR already set. 03475. 03475. 19 and 66. 19 and 66. Okie doke. And there's a grid cap on the tube, which we can now plug in. If you just heard a bang, that was my head hitting the microphone. Uh-oh. The grid cap has disappeared here. Okay, I'm going to have to stop and try to find out what happened to it. Where did it go? It's fallen out somewhere. Yeah, I'm going to go hunt it down. Well, I didn't find the one from this tube tester, oddly enough, but I got another one here anyway. And it says a grid cap. Now this won't snap onto the top of the tube. It's not quite the right size, so I just hold it. It really shouldn't be a problem. And we're ready to go on the test. This tester gives you two values that you're going to read on the meter. It gives you a value, the lowest value, and the like new value, if you like. So the lowest value for this tube is 915. So up here, that would be about there on the scale, just so you have an idea. So first thing we need to do is look for shorts. So there's a short light we're looking at. If the light stays on, there's a short in the tube. No. And then most tubes are pressing P4 and watching what happens. So we've got a reading there of around 1200, something like that, 12. So that's right in the middle between the reject and the good point. So good tube. This qualifies as a good tube. Typically in a radio like this has got 9 tubes in it. I think that's the count. You might find one or two bad tubes, but I mean they might all be bad. Who knows, right? But typically that's what you would find. So yeah, so either right in the factory or somewhere so these clips here are steel. They're steel because they need the springiness, right? Other materials don't have any springiness in them, but steel does. And so you can make a clip that's going to grip and stay gripping for its life. It's not going to soften up and release. The problem with it is soldering a wire to it. These ones are soldered up. I don't know how they did it, but somehow they did it. It's a nice job too. So I don't know, special solder, I don't know. But often there's no solder here, and the wire is just squeezed down onto this steel, and these present problems. Not in this radio though. These are all soldered. I guess they gave up on the problems they were causing and managed to figure out how to solder. What's this guy? 6J7. 6J7. Okay. The thing about these roll charts too is that they tend to roll a bit. And every time you look back at the chart, it's a different line that's showing in the little window. So I just have to be HIJK7. There, it'll sit there now. 6.3 volts JR, then 0347 with a 5. 0347 with a 5. Very same. Arrangement 19. Oh, you know what? I got the wrong tube here. J6J7. Jimmy. That's just not going to sit here. Okay, 6J7. Let's try this again. 6.3 JR 0347 with a 5. It is the same anyway. 0347 with a 5. Yeah. 22. A little different there. And 58. This control that's called English, it enables you to use this setting on the meter. So this control here that's called English, you can set this to English, and then you're just reading the English words, replace or good. And I usually put it on the actual measurement scale, so it's a 3000 scale. This English control means nothing at that point. 6J7, 58. But I'll set it anyway, because maybe I'm wrong. P4 grid cap. Here we go. I'll hold this cap on. You have to give it a moment to warm up. Probably the minimum for letting a tube warm up is like 15 seconds, but you probably allow at least 30. And you can tell though, if it's not warmed up completely, then the pointer will be drifting upwards still. Okay, so I'll hold this on here, do this. Watching the light now. No shorts. 6J7. The reject point is 770. So it's just a little ways up here. 770. Can you beat it? Oh yeah. Oh yeah. She's good. There's another winner. People tend to think these old radios, the main illness in them is going to be tubes. People who don't know, of course the main illness is capacitors, but tubes, sealed in a vacuum. have a very unusual tube here. I'll show you in a second here. Let's pull this out. Okay, so you see what they did here. They felt they didn't have enough pins, so they put a pin on top. And this pin is attached to the grid. That's normally what's up here. Not always. Sometimes that's a plate cap. Give you a big shock, but normally that's the grid cap up on top. This is a 6A8 tube I pulled out. There'll be a tube called a 6SA8, and this cap is gone, and it's all on the bottom. The S stands for single-ended, not double-ended. But have a look at this tube. Here's a really old one. This is from 1925. It has a cap, 4 pins, and a cap with 2. These are the heaters up here, and in this tube, the heaters are fed from the top, and these are all the business pins down here. So this is from 1925. That's a Rogers Type 32 tube. Has a warning on it. Warning: positively no adjustments if this label is removed. And there's a serial number, a selling serial number, 3607. Maybe I could write in a book who he sold it to, because if you come back a week later and go, this tube's no good, which is a good chance it will be no good, they don't know what to think. Would you buy it from us? Who'd you buy it from? Where'd you get that? So that's why everything was registered. And then if you did bring it back after a week, they'd say, you got a week out of it? Well, okay, we'll reduce the price on the replacement tube by, I don't know. I guess in a case of a week, they reduce it a lot. Maybe give you the next tube. Okay, so tubes are very unreliable back then, but not by the time they looked like this. They were not unreliable. Having talked all this time, I'm now not sure what I'm doing. Let's just make absolutely sure. Yeah, 6A8. I totally lost what I was doing. 6A8. 6A8. It's funny how all this knowledge that you might acquire about all this old stuff would take a long time to acquire it. For me, a lifetime. And seldom would you come across documentation or strongly supportive information, although there's some books out here and there. But getting a schematic for a radio 30 years ago, I don't think it was going to happen. You had to go to the big library in Toronto, wow, to get a schematic for a radio, and people did that. Now I just have to say something to my computer and it'll give me the answer. What a world we're in. 6A8, concentrate. Concentrate, yes. 6A8, here we are. Two tests for this tube. First test, pentode section. JR 0347 with a 5. And same thing again, 0347 with a 5. Wow. 22 and 50. Goodness, at least one number different. Make me feel like I'm doing something here. Okay, grid cap in, or tube in. So this one is supposed to be above 630. 630 is just above where my thumb is. So I'm not paying close enough attention to the camera today. Short check. Nope. The flashing is harmless. P4 600. Well, it's well above. So you think in the life of a radio like this, what would happen is it would be in use, and then one day somebody would go and turn it on, and it wouldn't work right, and they'd say, "That's it. I've had it with this radio. We're getting something new." And they'd put this away with one problem in it, whatever that one problem was, that made them stop using it. So I wouldn't be too surprised if all these old radios have at least one dead tube or one serious thing going on in them. The capacitors will continue to deteriorate whether it's operated or not. The tube, I guess, because it's in most of the the tube is in an evacuated sealed cylinder. They don't deteriorate. 6K, another 6K7. Shoot, I wish I'd known that. I would have done it with the other 6K7. Once again. $6K7 03475 03475. I don't have to change these buttons at all. 19 and 1966. You gotta wonder too, what kinds of things have these old radios heard? These were in big use before television. This was the house entertainment. It was on every night, I'm sure. And so obviously they'd listen to the news through the radio, so all the current events would have gone through this thing from back then. Okay, this must be warmed up. Back here. P4. Oh, didn't read the numbers. 6K7. 1450 is the high number. It's more than that. It's 15 something. How does that happen? That happens because something's not set right. 6K7. As I'm talking, I'm not. I lose track of everything. 6K7. $0347 with a 5. 03. Yeah, sure. Haven't changed those at all. 19 and 66. 19 and 66. Well, it's extra good. It's super good. Okay. So far, very good turnout here. The next one is a little stubby tube. 6H6, I'm sure it is. H6 dual diode, very commonly used as a detector. Hey, that last tube had two tests. That last tube didn't it? No. The one before it had 2 tests. I only did 1. I'm not going to worry about it. JR 05070. JR 05070. 0507. 061. You gotta be on English for this one. P1. You push button P1. Diode number 1. Okay, we'll give a bit of time to warm up. I'll try to think of something to say. What could I say? How about look at my cat down there? Well, cat entertainment while the tube warms up. What are you doing? Looks like he's looking for something. Is there something down there? He thinks there is. Okay, tube's gonna be warmed up now. No grid cap. Shorts, P1, and it should just come up into the good. Oh no, take that back. P1, diode, so it should just pass this thing where it says diode's okay. And it does. That's one test. 6H6 0304. 0304. Tab number 2. She's a winner. Okay. Now, I've got one last big metal tube here. Oh, there's another metal tube in the back too. Look at this thing. This is a 5T4. This is a big rectifier tube. Pretty sure. 5T4. Well, the giveaway is the 5. 5T4. Here we are. 2 tests for it. So heater voltage is 5. The heater pins are HR. And we're 0, 6, and all zeros. 0, 6, and all zeros after that. 0, 55. English. Press P3. Rectifier, not the diode rectifier. In this case, it's replacing good. Okay, this is a big whopping tube. These things sometimes draw pretty good current. So we'll check these testers have an adjustment for line voltage. It's right here. So we will do that. I see it's right on with where it needs to be, so it's just fine. My voice is a little hoarse today. Okay, shorts. Now the owner of this radio told me he plugged it in just before he gave it to me. Plugged it in and gave it a shot. And so I wouldn't expect to find any shorted tubes, because he heard hums and stuff come out of the speaker. The radio didn't work, but he heard stuff come out of the speaker, which is a very good sign. What am I doing now? Concentrate. P3. She's a good one. Now we do the next thing. We change the 6 to a 4 and reduce the English to 49 just a wee bit at P3. She's good. She's a good one. Very good. So I got one more metal tube. Might as well do it for some reason. Wow, these grid caps are really hanging onto the tubes. 6F5. Now that's not so common a tube. 6F5. 6F5. Okay. 6.3 volts. JR. 04072. 04072. That's my cat going under the bench here. He's underneath the bench here somewhere now. Which is a crowded space, believe me. 0 with a 2. Yeah. 12 and 52. 12 and 52. 12. Not many pins. In a lot of these tubes, if the tube didn't require a pin, they didn't put one in the tube. Well, why waste the money on a pin building the tube? What are you doing down there? Oh. I see you. You're not hiding. I see you there. Okay, that's the cat entertainment, this part of the show. Back to the tubes. Okay, grid cap on. Short check. And for 6F5, it's gotta be P4, yep. That's a low reading. What's it good for? 6F4. Cool, 6F5. Jim, what have you done here? Hold on, everybody step back here. 6F5, right. 6F5. Yeah, 600, that makes more sense. So it should come up just past the 500 mark here to be good enough. Here we go. What's well above it? Another good tube in this radio. Did I say I took this radio out and cleaned it up outside? What a dust bunny. I guess if you saw it yesterday, here it is without any dust on it now. You may not remember what it looked like, but wow. It's like the dustiest radio I've ever come across. Okay, so from here there's 1, 2, 3 more tubes to do, all glass. For some reason I'm going to stop and do the coffee thing at this point, and then we'll finish off the tubes there. Okay, so the remaining tubes now are these, I guess it's just 3 glass tubes, and one of them is in a bit of trouble already, so I'm going to show you that. Oh, I see. Bert has found it already. Bert, get off my keyboard. Not on the keyboard. Fortunately, I have an on-off switch on my keyboard. I keep them off all the time now because the cats walk on them. Yeah, that's what's happening over here. Let's take a close look at this particular tube here. You can see the grid cap is coming off the tube already. And you can see how they've somebody squeezed these grips, maybe even in the factory, so they're really sprung on there. Okay, how loose is it? Let's see. Oh, that's easy to get off. Huh. I'm being totally nudged by a cat here. What is going on? Yeah. Okay, got that off. Let's get the tube out here. Here, hold on to this camera, cat. Okay, tube out. What to do with my little screwdriver? This is a 6F5. 6F5. Made in Canada, 6F5. Okay. 6F5, eh? That's just 2 tubes further down the way here on the list. Okay. You're going to help out, are you? We're doing a 6F5. 6.3 JR 04072. 0407. Same settings. Okay, 12. 12 on the bias setting, and 52 in English. 4. Cap is G. What are you doing in here? Haven't you got something more interesting to do? Go chase your brother? Look out the window? Apparently not. Okay, this is our momentary cat entertainment here while the tube warms up. Okay, he's thinking hard. Okay, first thing we do is, oh, we have to turn this on. Okay. Once again, back to the cat entertainment. Can you look up? Can you look down? Can you look back up? Very good. Where are you going? Okay, he's leaving. That's probably a sign the tube is ready. Okay, thank God for a cat. Now, here we go. So just barely saw a flash here. No, that's better. If you do this test and this doesn't flash, many times it's already telling you the tube doesn't work. 6F5. 630,000 is like new. So 630 on the 3000 scale is just here. Well, it's just above 630. It's still climbing too, so it's still warming up a bit. Okay, well that's not going to stop the radio from operating. If it's not in the best of shape. Okay. Wow, they've kept these wires as short as possible here. Okay, that's back in. These two tubes look identical. I wonder if these are each a like a single phase rectifier. What am I doing? I'm looking for this little screwdriver. .6K6. No, that's an output tube. This is probably a 6K6. It's probably push-pull. Oh yeah, that's right. This is the rectifier tube. What are you thinking, Jim? 6K6. It's a good thing I'm here to keep myself straight. 6K6. Okay, 6.3 JR 5347 with a 0. 5347 with a 0 on the end. 34 and 67. 34 and 67. Okay, 6K6. Yep. So what is this other tube? Oh, it's going to be a 6K6 also, as I mentioned already, for push-pull output. That's my guess. Okay, shorts. Oops. Camera, Jim. Shorts. None. 6. So it should be 1,000 at the lowest and 1,600 for like new. So up to about here. It's got to be higher than here. Way up there. She's a beauty. She's a beauty. Push-pull output gives you lots of power with little distortion. And they're very efficient. More efficient than just a regular single tube amplifier. 6K6. So they're very, very attractive, but they require a transformer, a center tap transformer, require 2 tubes. So it requires a little more to do it, but the result is good. That's why it's so common. This is my junior Run Bacon testoscope from Manchester. This was mailed to me, arrived at my desk when I was working 30 years ago from England as a demonstration. I'm working in a power company, and they sent me this thinking it would be useful because it has a little indicating neon light here, and you know, you put your finger on the top and put it on your circuit and see if the light glows. Well, I'm not going to do that in a power company. Okay, and you can see I've hung on to it all these years. So here we go. Any shorts in this tube? And the answer is no. You push the button. She's way up there. Excellent. There's only one tube left, and that's the Magic Eye tube. So the chances are really good the Magic Eye tube is worn out. And also, the chances are really good that there's over here, there's a defective component inside inside the tube socket. Get this off. These are horrifying. Let's try this. Don't break it. Okay. And getting them out of the socket's not easy either. There it comes. Okay, here it is. 6U5, a very common tube. We can test it in here. 6U5. QRST SSSTU 6U5. Here we are. So one test open eye, other test closed. So the test is 6.3 JR 6U5 5403 5403. Oops, 3 5403 0. Doesn't matter. Press P4, eye should be open. Then we change a couple numbers. Press P4, eye should be closed. Okay. And for the big pins, here they are. There's usually an arrow. There's an arrow between the big pins to help you not make a mistake. In she goes. Now, in order to see that, I'm going to have to darken the shop here. So I can see the heater is glowing. There's nothing showing up on the tube. To press P4 to actually energize the tube. Okay, so I guess we do the short test. And P4, she glows, and it's open. That's pretty good. Okay, that's really good. And here, eye closed. If we change it to 542, if we just add a 2, make the 0 into a 2. Yeah, make the 0 into a 2. We push the button. Closed. Perfect. Wow, okay, that's surprising, and that's great, because these tubes are getting up around $100 a piece now, and they're getting to be really quite rare. So for now, I'm just going to leave it out of the radio, because there may be issues, as I mentioned, with a resistor that's commonly installed in the socket and not under the chassis. And these wires are as stiff as can be here. Look where they're running. They're running between these tubes. So this is a cookout here. These things get roasted every time the radio's operated, and so they are just stiff right up. So I don't want to fool around with this at all for now. I'm not even putting the tube back in, because every time you put the tube in and out, you run a risk there. So we're just going to leave it out for now. That's it. The tube testing is done, and son of a gun, they're all tested good. Even the Magic Eye, which is a really quite surprising, but that's great. That's also great. So that brings us a big step closer to operating this radio. Now the owner did operate it before he brought it over here. His comment was it hummed at first, and then the hum got a lot louder, and I think he probably turned it off at that point. The humming is almost certainly from these filter capacitors being insufficient, and without even operating the radio, we can pretty much guaranteed that these have to be replaced. Now you don't have to replace them with these great big tube things, because modern capacitors that do the same thing are just little guys. So if I put a couple of little guys underneath here, I don't think I should operate it the way it is now. The real question is, should I go any further today or not? So if I look at the clock says 9:30. That's pretty early, and it's rainy outside and wet. So why don't we go a little bit further here, and I'll keep pushing towards operating the radio today. The key to that then will be dealing with these. I don't think we should bother trying to operate with it without dealing with these. Okay, that's the plan. Drinking coffee now. Okay, we want to make some observations in the radio before we do anything, but look, here's my grid cap I couldn't find before. Here it is. Okay, so the capacitor's here. The bottom of it is right there. And we want to look at is how is it connected in relationship to the chassis. And what I can see, and you might have some trouble seeing from there, let me put a little more light on, is there is an insulator down under the clamp here. There's a clamp you spin down to clamp the capacitor in place, and there's a rubber I can see here. You can also see wires. This wire is soldered to this the clamp part that you turn around. So it looks like the shell of the capacitor is not touching the chassis. That's what it looks like. If you look from the top, sometimes you can see all this from the top too. So this is the capacitor here. I mean, again, hard to see in the camera maybe, but I can see the rubber insulator like a gasket just down under here. So this is not touching the chassis. There's a reason for that. This is not running at chassis potential. Now there's another one, this one back here. Let's see how this one's done. So this one's a little harder to see. He's buried under here. So I can see it though. And what I see is the same thing. I see also another rubber insulator or some kind of material just under here. So, okay, so this and this, they are not running at chassis potential. That would mean if you went like this and like that, you'd be probably not risking too much, but there might be a voltage between here and these things right here. So I don't think it's a shock hazard offhand. Let's look at the schematic now and see what it tells us about these capacitors. These are important things to know before you go to install replacements. So we will check out this will be the first time looking at the schematic too. So the main reason we're looking at this right now is just to look at the way in which the filter capacitors operate. We'll do that in a moment, and then after that we'll take a quick scan through the radio here, just looking for anything that might be revealing, especially this motor stuff. We'll just look at it a little bit, not to try to understand it fully, but just to kind of become aware of what is in this schematic, how it's structured and stuff like that. So the capacitors we're interested in are down here, probably this one and this one. We're going to zoom in on this part here. A lot of parts in this radio. So here we see the rectifier tube. This would be the 5T4, that big metal tube. And out of it comes the positive terminal or charge. And right here, right away, it meets up with one of those two tall capacitors. 25 microfarads, a little bigger than I would have thought. And then it goes through the field coil and meets up with the other capacitor here. Now, a lot of radios, the bottom of the capacitor is grounded right out. But see, it's not. Here's the ground potential, and there's a resistor here. 12 ohms. 12 ohm resistor here. And what they're doing is they're shifting. It's a little hard to explain, but if you look at these resistors and just forget about them being in this radio and just listen to what I'm going to say. If you put a positive voltage here and a ground point, let's say where it's showing here, then you will get a progressively positive voltage as you go up here. And if you put your meter here, no matter what you do with it, you're not going to find a negative voltage. How could you find a negative voltage? This is grounded. This is the most negative spot. But what would happen if instead of grounding it here, you moved this ground connection to here? Well, of course, forgetting there's a radio out here, just considering these three resistors, if you and ignoring this one here, if you move the ground point here and you put your meter, negative terminal here, you measure up here positive, measure up here positive, measure down here negative. My gosh, you found a negative voltage in the radio. And the negative voltage is useful because it can be used for biasing tubes. That's the whole reason for doing it. That's what's been done here. Instead of putting the ground point right on the bottom of these capacitors, typically, quite commonly, these two capacitors, the negative side would be tied together and right to the chassis, and that's very common, but not in this radio. They aren't tied together. There's another resistor in between them, which is kind of interesting. It may be creating another negative voltage. So we ground here, positive up this way. So these things are heading towards plates and screens and stuff like that. And if we go this way, we're heading towards grid voltages. So if we follow this line, see if I'm full of crap here. We'll follow this line and see if it doesn't go to a grid circuit. Okay, R29, still going up. That guy's full of crap. It's connected to a plate. What about over here? Bottom of the volume control. This is connected to the grid. Aha! That's a grid cap going to the grid. This tube's upside down, plate at the bottom, and the cathode at the top. Okay, so there we go. So I'm sort of semi full of crap. I don't know. There's a ground point here and a capacitor. So I think so I think generally what I said is true. Specifically, what's going on with this radio, maybe I'm full of crap, but I don't think so. So the important thing is, though, if you're going to do something like this and try to create a negative voltage in the radio, then these capacitors can't be tied to the chassis. And when I do the replacements, I have to imitate this exact connection. I can't, it might be easy. I'll throw a couple capacitors in and ground them to the chassis over here. No, that's going to ruin this radio. So we have to be a little careful here. And that's what I want to do. So I'm going to put in a 25 and a 16. And what's the voltage on these? Well, it would have to be fairly high. Is there any hint on the voltages? Sometimes they write them up around the plates. They write them near a wire. I don't see any statement of voltage here anywhere at all. So they're not revealing that on the schematic. Here's some down here. Well, here's one here. 230 volts. 232. What's this? 33 ohms. 333 ohms. 25 side. Oh, I think what they're trying to say is this transformer has an impedance of 333 ohms at 25 cycles. At 60 cycles, it's 232 ohms. I think that's what they're trying to say here. Does that make sense? The higher the frequency, would you get a higher resistance? Yeah, I don't know. Got it over here too. These radios that were made for 25 cycles work really well at 60. What else? Okay, so I sorted this out now and ready to do the work properly and safely. Let's just look at this situation though a little bit more here. So what about that fuse? So I think the fuse I saw is a fuse on the supply to this motor. Where's the supply? What's it doing? Going way up here? What's it doing up here? I don't know. Did I follow the wrong wire? Maybe I followed the wrong wire. Tuning motor. Tuning motor. I don't plan to figure this out. Here's all the contacts, and this is the selector disc. Oh, look how they've done it here. So the disc is a two-part disc with an insulator in the middle. And that means, what would that mean? So wait, if you push one of these buttons, assumably they're all showing in their relaxed state. Look, they're all closed switches in there. Oh, what's going on with this one? How come he's pushed over? So this part must represent the actual button that your finger touches, and then you push this over. Why they are showing number 4 over? Maybe it's just to show you what it looks like when one's over. Let's follow this one. So you're shorting these two lines. Oh my gosh, you got to go through all this to get out of here? Every one of these contacts could be bad. That's what you got to do. Wow, okay. Well, again, I don't expect to figure out how this works. I just want to make observations. Red, yellow, dial tuning What is that? And there's a ground here. There's a couple buttons that do different things. There's a couple buttons, like one that's going to turn on the phono, and another one. So this probably means that this switch is joined. So it's probably what that means. Yeah, there you push this button, operate these two switches for some reason. Okay, so I kind of got the selector disc a little bit figured out. 6.3 volts being brought over through station selector and dial lamp. Station selector and dial lamp. Well, there's a funny light in the middle of nowhere on this thing, and the bulb is missing, and that's probably this. And so you're turning this light on and off. Perhaps when you put the radio into a mode where you're regularly tuning it with the dial, this light is off. And then when you put it into a mode where you're operating these buttons, maybe the light comes on to tell you that's the mode you're in. I don't know. I don't know. But we don't have to know right now. We just have to have a notion. Put a charge in my brain. Let me tell you what I did with my two sons to put a charge in their brain. When they were 15, and that means they're getting close to getting a driver's license. Here in Canada, you can get one when you're 16. When they were 15, almost 16, I took each one out alone, just me and my one son, to a large commercial parking lot in the evening where there's no cars and no nothing and no curbs and no nothing. And I had him drive the car around in this parking lot just for 2-3 minutes. I had him, drive the car forward, figure out the brake. All I wanted to do was put into their heads what it really feels like to drive a car a little bit. And just get that in their head to displace any imagination that they had, or maybe they just were empty-headed about this. Let them have a little experience. Now they got that in their head. Next 6 months, while they become 16, they have that in their head. When they go to learn to drive a car, they're already one step ahead. That's my thinking. So that's what I'm doing with the schematic. I'm just looking this stuff over to get some stuff in my head. I'll let it churn around while I do other things. And when I come back to this to really understand it, I'll probably be in a better shape than I am now. Okay, well, while we're doing that, let's take a look at a few other things, like how is the speaker done. So we see there's a humbucking coil in this speaker, and the idea here is because this, I'm sorry, not this winding, the field coil winding, which they're gonna, here it is. This winding will have a bit of a hum in it, and the hum will be transferred to the speaker cone. You're going to hear it. So they put a reverse hum or a anti-hum here to buck it, and buck against the hum that's got to be coming out of the field coil. And maybe if there's a touch of hum in here, maybe this bucks it too. I'm not sure about that. And here we have the push-pull arrangement. The two tubes in push-pull. Then we need to have an inverter tube. Here it is. Inverter tube. 6F5. We have two. I don't remember. Did I test two 6F5s? Did I miss a tube? I don't remember doing two 6F5s. Okay, that's a magic eye tube there. Here's the detector tube and all the rest going down. Let's look at the antenna. We'll forget about what's in between the antenna and the speaker. We'll just look at the two ends here. So here's the A3, A2, A1G situation. So A3, well, let's back up a bit. The idea is to get the antenna signal onto the grid here. So we can trace the grid back. Goes into the switch here, which is selecting one of these coils, or maybe multiple selections. Now they're showing one primary here, and the secondary is way up here, but that's, of course, that's just on paper. I'll take this back. I'm taking this back. There's a coil here. These two seem to be associated. Well, I don't know what to make of these coils. They're just kind of out here in the blue. Is there any wire running between? No, there is not. So the only way any antenna signal gets into this radio is by going through a transformation of some sort here. So even though this is showing kind of out in the blue, it must be close to one of these two coils. Now often the way they rig these radios, they have like one antenna for doing broadcast, AM radio, and another antenna for everything else, for the short wave. So my guess would be these two are intended for listening to broadcast. You know, it might even be written right down. I don't have to think about it. Range switch showing in A band position. Okay, don't worry about that. Yeah, there's no switch in here. There's a switch here, but there's no switch in the front here. The switch is kind of how you hook it up. So you can have a loop antenna driving the broadcast, and you can have a wire antenna doing the shortwave at the same time. That's why they have so many terminals back here. And what's the use of the ground? Well, I guess if you want to put a ground rod down or something like that, I guess you would connect it here. But as for your antenna, you can think of it this way too. If you have a wire antenna out in your backyard, like everybody used to have so many years ago, and there's a signal on the antenna. It needs to. This isn't really the right way to look at it. It needs to push against something. That's I'm going to forget it. What I was going to say, I don't think it's too helpful. But the ground, I found with my experience, the ground sometimes helps and sometimes doesn't. And I don't have a ground rod in my house. I don't. Yeah. Who did that? But I think the antenna would work better if the radio is well grounded. Now you're plugging this guy into an outlet. In the long run, there is a ground sort of through that, even with a two-pronged plug. Not much though. You see here at the bottom they have a capacitor. It's a small one, 15 picofarad to the chassis. They have a resistor to the. Oh, look at this! They have some tuning trimmer here also to the chassis. So this guy must be tuning against this or this, one of these two. Okay, so when engineers are designing these things, as I mentioned before, I think one of the main focuses is the coils and transformers that are unique to the radio. And this would be a great example of, they have to design this thing to get it to work the way they want it, but they have to make it so it can be manufactured cheaply at the same time. So they've got a lot of focus on these coils, I'm guessing. And all this stuff in the middle. I don't think we need to look at any of the stuff in the middle yet. Okay, so that's a good sort of first time through the schematic, what is going on, and we're going to deal with these. I'm gonna put in alternate capacitors here. I will disconnect these ones and get them out of the circuit entirely, and away we go. It's quite a fairly easy job, I think. Okay. Okay, look through my capacitors and oops, dropped one. I'm going to put in two 22 microfarad 450 volt capacitors here. Just put them across, and then I will disconnect the positive terminal here, but try to leave everything just exactly as it is otherwise. So it's really quite easy to do this particular radio. So just basically negative down there and positive up here, and nip that. And then this one that's in behind here, yeah, it's got a lot of junk coming out of it too, a lot of powder coming out of it down here. This one's a little harder to get at, but let's do the easy one here. Well, I'll have to let the camera continue here. So there's my heavier pliers. Where'd they go? I don't know. Okay, so I want to make sure the positive lead is the one I put up on top here. Okay, and the negative one can reach down to here. Okay, how about turning on my soldering iron here, think I saw the solder over this way. Where did I see it? It was in here. It's in a strange spot. Here it is. Quite a bit there to heat up. There we are. Okay, now the negative lead. The pliers I'm using are not appropriate for squeezing, bending stuff on that. These are just grippers or holders or picker-uppers. But the leads on these capacitors are fairly thin, so I think that would be okay if I just... Can I get in there? Yep. Okay, one done. Oh, I have to cut the. I have to cut it here. Oh, yeah, like that. Almost got it. Come on. Oh my gosh, what's holding it on? Maybe I've got a divot in my tool here. There we go. Okay. Did I wreck everything doing that? No. Seems fine. Just move this over there. Good. That's it. That's all there is to that. Now, what about this? So I should probably replace this at this point because it's in the way. If I just cut it, like once I cut one lead, might as well change it out. It's a big capacitor too, so why not? It's connected to this resistor. This is probably the same resistor I was showing you on the schematic and talking about, you know, the voltage drop and negative and all that stuff. This is probably the resistor that's doing it. You say 1, 2, 3 terminals up, and there's a big capacitor, and it is connected to. What is it connected to? It's connected to a particular 2-pin, but this terminal here, which I know you're having trouble seeing it. There is no 2-pin in the socket here. There's no. So this is a spare terminal, and engineers love to use those for making connections. So basically it's a capacitor off this. So there's another capacitor off this too. This is the bigger one though. So if we can figure out where this is on the schematic, we'll figure out what that is and be able to maybe know what it's doing. So let's take a look at that. Okay, so it's right off this resistor here, and it could be this guy. No, that's the one I'm replacing. Can't be that. Well, let's just go through it. So it's not at the end. It's 3 in from one way and 4 in from the other. So you go 3, 1, 2, 3 in from one way, and well, there's no 4 the other way. There's no 4 resistors. Okay, that didn't work at all. This may not work out. So it's a big capacitor. Maybe there's a little too many capacitors in here to go wandering around looking for it. There's a big one right there, 0.1. Probably on the screen, yeah, screen grid. This could be it, except the one I'm looking for doesn't go to ground. It goes to a resistor. You know what, I'm not going to find it here. So what I'm going to do is I'm just going to remove it. See the size written on it. Oh, this might not have the size written on it. This kind of capacitor. It's a Philco style capacitor, and they tend to have a serial number but no size. I'm looking at it right now. It's a big honking. We're going to have to figure out which one it is. Oh boy. Yeah, wow. Well, let's just look a little further. So maybe on this line. It's right off the resistor, so it can't be on the other side of another resistor. It's right off of... Well, maybe I'm wrong. Maybe this isn't. Look, see, there's another resistor here, one up here. Maybe those are in that thing. Oh my gosh. 0.01. I don't think I'm going to be able to know for sure which one it is. It's an important one, though. How am I going to figure out the size? Well, the biggest thing here is this 0.1. Is there something bigger in this radio? Probably not. Well, I can look in the back of the radio, which I am doing, and yes, there is. There is another gigantic. There's two more giganto capacitors in there. So yeah, I don't know what I'm doing here. I don't know what I'm doing. Yeah, so there's this guy, but there's also this one, and then there's another one tucked way up in here too. Great big things. I'm pretty sure this does not show the actual size. It says 200. That's probably the voltage. Okay, it's coming out anyway because it's in the way of me doing work down here in a secure manner. So we're going to cut it from here, and I'm going to immediately put a clip lead there to mark it, so I know that's where it came from, because I have a short-term memory. Because look at all the powder in there, right? It's just a big packed pile of powder. This capacitor's got some kind of funny bump. Oh, that's just a drip of wax. Well, I might as well cut it right out of there. So this time I'll leave a bit of wire to mark where it came from, and without taking my eyes off it, I will stick this clip lead there. The clip lead now shows where the capacitor goes. Oh boy. So it's got some numbers on it here. 0.25, 200. I don't know what that is. So it's a 200 volt, 0.25 capacitor. 0.25, that is a big one. Okay, I gotta look around my stuff, see what I got. 0.25. Well, it turns out I've got one, but look at the condition of it. I don't think this has ever been installed anywhere, but how did it get all this dirt on it? Let's test it. See if it shows 0.25. So it's 231 nanofarads, which is 0.25. Loss is 0.1%. This is in good shape. Okay, it's a nice looking capacitor. Like, it's got a heavy duty seal on the end. It's not soft. So I think, yeah, this is going in. So I'm going to put this in place of that. But before I do that, I want to deal with this capacitor. Have a closer look at it with me here. Just hoping my camera will focus. Did I put it on fixed focus? I don't think so, did I? Maybe I did. Okay, let's pretend we did. So you can see things are soldered to the tightening nut, which is kind of a weird thing, but you probably can't solder straight to the can. So they've soldered to the tightening nut, but the tightening nut, I mean, it looks rusty. You know, is it really making electric contact? Probably is. So I'm just questioning myself as to how I would rely on it. Let me take this off for just a sec. there's that cracked wire, and there's look at these ones. This green one here, and down below there's one down, a yellow one down there. Ooh. Be very careful to not end up having to rewire the set. I've never done that. I think that, that's another level. So the connection, where's the connection to the top? Is it all just eaten away? Oh no, here's a wire here. I'm gonna clean this up so we can get a good look at it, and I've got to do it with a vacuum cleaner. So just give me a moment here, and I'm gonna vacuum this stuff away. Okay, now we can get a much better look at that. Yeah, I guess I turned off the automatic focus here. So we can see again, the deal is there's usually a number of wires connected to these terminals, and that's why it's handy to maintain the terminal and just cut it free from the capacitor. You don't have to move all these wires. Look, there's a bare wire. That's a little odd, isn't it? A bare wire? Off of here? This is a high voltage terminal. Why would there be a bare wire on it? Where's that wire going? Well, it looks like the insulation is off it. Like it looks insulated down lower. I think it burned up. What can I shove down there? Let me bring a little better light over here. Where am I looking? Down here. So the question is this, did this wire burn its insulation off? Oh, I can't imagine. If it did, that would produce copious amounts of smoke. And I think it's just dirt on there. Can I just see if I can get my toothbrush in there? No. Get another brush here. Give me a small brush. Well, it just seems very odd to me that they would run a bare wire down there. It doesn't look very well soldered either. Huh. Well, I don't know. It's there. I can't imagine it just sort of showed up on its own. It's got to be in there for a reason. Okay, so what I'm going to do then is I'm going to solder in the new capacitor here. Oh no, I want to solder in that. Jim, wake up, man. So again, we want to go to the top of this resistor. We want to put the positive onto the terminal here. There's no chance that's a negative, eh? Is that possible? I don't think that's even possible. So I think what I'll do, I'll just kind of wrap this around here. Like so. Yeah, I'm pretty sure we're going to try this radio out today. We're going to turn it on. Part of that is because the owner turned it on and nothing horrendous happened that we know of. Anyway. And I think there's a good chance it'll work. I'm not saying it will work. A lot of metal here. We'll take a close look at that. Let's take a close look at that. Ooh, that doesn't look good. It's solder, but I think I can get a little more solder on it here. So today is a cool, rainy day outside. In fact, my furnace fan my furnace came on just a while ago. Put heat in the house. I'm a little bit surprised. Okay. We want to get to the top of here. So regularly I don't show me doing this kind of work right here because it's fiddly and it takes time, slows me down too. While the camera's running and I'm doing this kind of stuff, it definitely slows me down. And you know what? Mainly because I can't cheat. When the camera's running, I can't cheat. I think that'll do the trick. Let me just put some solder on it here. So will a radio, oh, what about the motor? What should we do about the motor? You know what, I wanted to spot the fuse, and I wanted to pull the fuse to stop this motor from operating. My guess is that's what the fuse is. Maybe we can see it. Maybe we can see that. Because the fuse is right above the motor here. That's pretty suspicious too. So let me put my finger on the fuse here. Okay. So the fuse is mounted right here. Is that? I've got my fingers right. Yeah, there's no wires to the fuse on top. The fuse terminals come through, and here they are. They go straight to the motor. So I'm willing to bet I pull that fuse out, this motor can't operate, which is what I want to do. We don't want that coming on. I don't know what I'm doing with this radio yet, so I mean, I could have it in a mode like, you know, something going on here to trigger the motor. Well, we're expecting, don't break these wires, don't break the strings, Jim. That's another big, yeah, there we go. Let's pull it. Where'd it go? There it is. Is it a good one? Oh, it's a heavy fuse. This is a big fuse. How big a fuse is it? $15 amps. You gotta be kidding me. 15 amp fuse. That's what you got in your fuse box. That's nonsensical. You don't need a 15 amp fuse to protect anything in here. You could protect that motor with a 3 or 4 amp fuse, couldn't you? 15 amps. Oh my God. That's just, I don't know. I'm glad I looked at it. Okay, we'll set that aside. The fuse is out. We think the motor won't go. Still, hey man, you haven't put this capacitor back in yet. I've made a stupid mistake. Did I make a stupid mistake? The answer is yes. I've made a stupid mistake here. Because I'm doing two capacitors at once. You know, if there's a way to get it confused, I'm going to find that way. I've gone and put one leg for this capacitor and the other leg is for the other capacitor. It should be over here. Oh my gosh, I'm telling you. I think you do enough of these and you stop making mistakes. I don't know, why stop making some mistakes, that's for sure. Apparently not this one. You're not coming off. You're barely... Oh, soldering irons. Time out on the soldering iron here. Glad I caught that. Stupid mistake. And that's a thing when you're doing this, you know, especially if you're doing it alone. I'm basically alone here while I'm doing this. If I make a mistake, what are the chances of me catching my own mistake before there's consequences? I managed to do it here, but okay, did I solder that on there? No, not at all. Okay, so I'm gonna tell you what I'm going to put that capacitor in proper. I'm going to put this one in, and we will be ready to operate this radio. Now, going down and getting my pliers reminded me of something I wanted to say. Now, you may or may not have watched me try to work on this large UHF VHF receiver for a couple of weeks there, pounding my way through it and getting a somewhat disappointing result here. Then I put it back in my listening spot, hooked it up to a better antenna, and good grief if it doesn't work well. In my shop, I think there's something wrong with it. I put it in my listening spot, there's nothing wrong with it. It still needs FM alignment, so it'll come back in the shop here for that. But I was so surprised because I was so surprised. So I just wanted to share that with you because you may have spent hours watching me work away on that radio and getting some improvements in it, but apparently not really getting it fixed. Well, actually it did. It wasn't broken in the first place. Well, it was. The big mechanical band change switch was totally frozen on that radio, so I get the cigar for that. Okay, I'm going to swing this one this way. Oh, I got to cut the old one off. Cut the old one off. Whoops. Cut the old one. Ooh, this is really tough. I got to go right through the terminal here. I don't know. That's probably a solid piece of metal there. Let's give it a go. Make sure I'm not cutting something I don't want to cut. Oh, it was easy. That cut easy. Okay, let's get a little separation here. That does leave this big clunky terminal kind of floating around in the back of the radio, but get away from that, would ya? Get away. It just wants to go back. There. Okay. Now we can put this guy in here, like so. Stiff wire. Oop. There we go. Get rid of all this excess here. Should have sanded the wire a bit, I think. It's pretty black. We'll see. That's not going to work like that. Down here. Whoops, wrong wire. Whoop. Oop. Yeah, this is why I don't normally show this part of the work, because it's too fiddly. But you're seeing it now. If I solder that, I think we'll be okay. Shaky, you're shaky this morning, Jim. How come so shaky? Because I'm almost finishing my second cup of coffee. Maybe that's why. Okay, capacitors in there. Let's review quickly. Negative in the right place. Negative in the right place. Connection solid. And did that get pushed back together? You know, I should have put a block in there, doggone it. I wasn't thinking. Nope. Nope. Yeah, let me put a little block in there. What would that be? A piece of paper, just about anything. Just about anything. That seems silly to put a piece of paper in there. This will kind of act as a flag to keep me mindful that there's something going on here too. I need to keep an eye on, because the work on the radio may push parts around a bit. This is not going in. There we go. And you know, I may accidentally. It's just a little tiny clearance there. I'll have to do something better later. Okay. Yeah, we're gonna plug this guy in. So the external insulation is shot, but the internal insulation on the wire itself is still intact there. So there's no short here. You know, maybe I should do something else. I should fire this up. I should apply high voltage to the high voltage circuits using my power supply here, and then just see if there isn't a short in the high voltage circuits. To do that, the speaker's not plugged in right now, so that means the power supply is isolated away from the radio. So if I power up the radio, the power won't go back into the power supply. It wouldn't anyway, I don't think. So maybe we'll set that up, and just sort of to prove that the radio does not have a short in the high voltage system. That's the idea. Or how bad the leaks are in the high voltage system. That's a good idea. The device I'll use is up here. Get that wire out of the way. This guy here. And it has a couple meters on it, a voltmeter and an ammeter, and I can kind of read the load the radio is putting on the power supply, and you can't do any of that with the internal power supply. At the same time, the rectifier will operate. It will produce voltage. It just won't go anywhere because the speaker's not plugged in. No, it won't produce voltage. I'm not plugging this in. Oh yeah, I better drink a little coffee here just to get even more jacked up. Okay, so the purpose of this test is to prove, or to supply some reassurance that something terrible won't happen if I plug this right into the wall. So this is coming down from my power supply up here, and I'm going to hook this up. I should hook it up to the first capacitor. Let's just look at the schematic here, because I just got a little nervous about where to do this. Okay, I really want to feed the power in right here, and I want it to be between here and let's follow this center tap. Yeah, you see the chassis. Well, maybe for this test it doesn't really matter, but if I hook up my power supply to the chassis, I'm not imitating the power supply here. If I hook mine up with the ground on the chassis, and the ground needs to be here to imitate it, but I am not really operating a radio. I'm not going to try to play it. I'm not heating any of the tubes up, so who cares? So hook it up to either positive terminal here. Ooh, no, if I hook it up to 1, I'm only energizing up this way. If I hook it up to this one, how am I going to know which one's which? I don't know which one's which. You think the taller one is the bigger one? Wouldn't that be the case? I think so. Okay, so the smaller one is the second one. Okay, I think I know where I'm going to hook it up and give it a go. I'll hook it up here. We can also try it here and see if the current is different. You know what? With it hooked up here, we won't energizing back this way. So I have to do this test twice. Once here and once here, because this field coil is not in the circuit. I am leaving it out. Okay, that's the story. Glad I looked at this. That is the story. So practicing. Well, you know what? This. Yeah, I can still do it. And I just argued that hooking it up between the chassis and that won't matter. So we're going to put the negative 1 on the chassis here. And we're going to pick the what I believe is the second capacitor, the smaller one. That's this one here. So we're going to go right here. Okay. Now come on up a little closer. I don't know if you're going to be able to read the meter. This should be down. Bad shop hygiene. Okay. Power's on. So this will show the voltage I'm applying, and this will show the current. And this is important to keep an eye on. The current here should be almost nothing. But as I turn the voltage up, you'll probably see the current go up and come down, go up and come down. And that's the charge flowing into the capacitors. Each time I raise the voltage, the more charge flows into the capacitors and charges them up higher and higher. So, so each time I raise the voltage, we would expect this to jump up and come down. A big radio like this, this might end up at 10, around 10, which is just here, barely off the zero. The red mark is too much for the power supply. Okay, we're all set to go. Look what I've done here. What a knucklehead. What a knucklehead. You think, you know, they make these black and red for a reason, Jim. It's me who did it anyway. Wow, it's just, sometimes I'm just can be so stupid. Okay, here we go. Going up. See, the current has risen a little bit. The voltage is up around 60 on here, but the scale's way off. The current went up and it came down a little bit. It's around 10 milliamps. So we'll go up higher. Okay, so I don't see any charging effect here. I don't see this going up and coming down thing. Let me just drop this. Oh my gosh, there's like no capacitor in the circuit here. Well, it's possible that the drain is so strong that as soon as I relax the input voltage, the capacitor voltage collapses because it's feeding into the radio itself. We're up around 150 volts here. So, you know, that's not any smoke on the radio, by the way. Should take a look. I don't see anything like that. We'd probably hear stuff too if it really went. I'm going to go higher because probably this radio is running with way up to 250 volts, 25 milliamps, which is a pretty heavy drain. Ooh. Just listening carefully. Don't hear anything. And now do the sniff test. Yes, I actually do a sniff test on this. Nothing whatsoever. Excellent. So we've checked part of the circuit. I'm going to move the ground to the place where this capacitor is grounded. So we're down on the voltage. Why am I doing that? Because I'm just uncomfortable with the fact that I didn't see a capacitor charging effect when I did this. So we're going to try it here. See what we get. Okay, up on the voltage again. So this time I'm seeing more of a charging effect. Oh no, not really. Okay, same thing. Not quite sure what to make of that. Okay, now we'll check the other capacitor here. Watch out, could be voltages in here now. Put the ground on the ground. Let's stick this on the positive. Right there. So energizing a different part of the radio now. That's what I think I'm doing. Here we go. We're going up. Okay, clearly there's no short circuit in here. Now we're getting the proper effect where you get jack up the voltage and you see the meter go up and come down. In fact, if I reduce it, this meter will go backwards, I think. Yeah, I don't know if you can see it or not. But okay, we'll jack it up. It should go up and come down. It's pretty quick. Okay, I went right up to 300 volts there. There's certainly no short circuit in this radio. It's ready to take high voltage, I would say. That's my conclusion here. Okay, make sure this is off. Right off. Right off. Disconnect this lead. Wow, we're one step away from plugging it in. I have to get the speaker up here. We're going to do it. We are going to do it. Okay, I'll get everything set up so we can actually power this thing internally. Just before we start up the radio, why not test the capacitor I took out? So this is a vintage capacitor checker. It works by putting a high voltage based on where this switch is onto the capacitor, and then if any current leaks through the capacitor once it's charged up, you can tell that from this very sensitive magic eye arrangement here. Let me see if I can just make it a little more. I'm trying to cast a shadow on it. There's a pi open at the bottom here. Yeah, you can see that. When I hit the switch down here, it'll apply the voltage. The eye will snap closed and then come open as the battery charges. As the capacitor charges. If the capacitor is not leaky, the current will stop when the capacitor is charged and the eye will be open again. It's a very simple test. Here we go. You see, look at that pop open. Okay, so that also is indicating a problem with the capacitor. This large capacitor should take a moment to charge. So something's wrong. What's wrong? Am I doing this wrong? Maybe I didn't make a connection here. Let's go like that. And we'll try it again. So it popped open so fast, that suggests the leads are broken inside the capacitor. In fact, let's go a higher voltage and see if I'm... Same thing again, just popped open like that. It's as if no capacitor is connected here. Wow, we may have found a really bad capacitor in here. Let's do this on a different kind of tester now. This was a high voltage test. We have a more modern device that doesn't rely on voltage but uses complex signals applied to the capacitor or whatever it is you're testing in here. I've had this for years. It just blew my mind away when I got this thing, and I don't think there's anything unusual about it anymore. Hook up any component to any one of those wires, even a transistor with three leads, hook it up. Don't tell the machine anything, just push the button. And this guy will figure out what it is. Huh. So there you go. It can't even test it. Fantastic. So I'm willing to bet... Oh wow, the end of this does not look very impressive, does it? It's a pretty chintzy capacitor. No wonder it's shot. There's a chance when I removed it, I damaged it at that point. There's a chance of that. Okay, that was interesting. Capacitor really bad. As if it's not even there. Okay. I think we're ready. So I need to tell you a little bit about how things work in my shop here. I've got so many new subscribers. I need to repeat a lot of stuff. So I'm not plugging this straight into a regular outlet. It's going into this guy here so I can read a little bit of information about the power going in the radio. This is just a regular extension cord. Can you see the ground of this thing isn't even plugged into anything? It's sticking out here. There's no ground coming along. This is supplied from a two-wire extension cord, so there's no hydro ground involved here. I've got a fuse here. And this goes around, things get really stupidly complicated. Goes through this switch panel here. Okay, there's nothing plugged in so I can operate this switch. Hear that snap? That's the unit being turned on, if you like. And this selector switch, if I push it down, power goes through these light bulbs back here, which I'll explain in a moment. And if I flip it up, it's straight from the outlet. Well, not really straight, as you'll see. Straight. It's without the dim bulbs if I flip it up. So you can hear the sound when I'm snapping these switches, because sometimes it's not on screen, but they have a very characteristic sound to them. Okay, so you can see this thing back here. Okay, so that I can adjust the voltage being supplied to the work on my bench. It adjusts the voltage on this thing. I can read the result here, by the way, if I care to. And this is also an isolation transformer, but I have another one behind it. Oh my God, how many isolation transformers do you need? You only need one. To some degree, the transformer inside here is providing isolation too. So, but that's not all. The dim bulbs. So if I flip the switch down, the power getting to the radio is passing through these light bulbs on the way. There's two light bulbs there. There's like this is a 60 and this is a 40, I think, if I remember right, 40 watt. Those are incandescent bulbs. You certainly couldn't do this with LED bulbs. So what that does is, let's say there's a short circuit in the radio I don't know about, and I power it up. That short circuit will simply result in the lights coming on very bright. Nothing bad will happen, no fuses blow, and with those lights coming on bright, I get a big message here at my bench that boom, something's happening. So it's not, I don't have to keep an eye on a meter or anything like that. Those lights will blast out. I can have both lights in if I want to supply more power, or I can have just one light in. Just unscrew one, I only have one light in to really restrict the power. And as the radio comes on and warms up during the first 15-20 seconds, the lights will do something which indicate stuff about the operation of the radio. So the expectation is I will turn on the radio, these lights will come on bright and then immediately dull down and sit for 5 or 10 seconds and then slowly come back up. The reason they're coming back up is because the tubes have heated up now and they're conducting more current, so the radio's drawing more current. Once the tubes get hot, everything gets going. So you see it come up. That's a normal pattern. Up, like that. 15-20 seconds. That's what I'll be looking for when we operate this. Okay, now I got to practice a bit. So this is the on-off switch because I can see the switch right here. We'll start with the radio off to make sure the off switch turns it off. And then this must be volume. This is probably tone. Let me look at the cabinet because yeah. Now there's not much labeling on here, oddly enough. There's no labels. Well, one of these is volume and the other one is tone. And quite commonly they put the on-off switch on the tone. And I guess the thinking was you set the volume where you like it and you want to leave it. So the tone is a less impactful thing. You ever, when you were a kid, did you ever have your mom or dad come in the house and go, "You left the radio turned up full in the car again"? I seem to remember that happening a few times. Okay, and this is interesting too. All this mechanics that are spinning in here are disengaged from the motor. They have to be while you're tuning it by hand. So this motor, I guess when the motor comes on, it must throw forward, and then when it's off, it goes back. What makes it go back? Mystery. I've got the fuse out, so this should not operate under any circumstances. I don't know what's going on with these buttons really yet, and I'm a little scared to push them because they're just copper pieces sticking out. It's part of the circuit. So you're sticking your finger right on a circuit. I don't know what it is. So okay, can't delay this any longer. I think we're ready to go. Speakers plugged in. Wires plugged in, power rather is plugged in. To keep an eye on this if we need to. Let me just check the escape path. Yes, my door is open. If I have to run for it, I will. I also have outdoor antenna ready to connect just if we get that far. Oh my gosh. Let's see what happens here. Okay, put that switch up. So I'm going to arm the system. Remember, the switch is off. And apply power. What happened here? Okay, something's gone wrong here. I notice my pilot light's not on. I think I know who to blame. Let me pull this out of here right now. The cats go under my bench it's just a pile of wires underneath this bench, and no doubt they've tugged on the wrong one and cut me off here. Well, okay, I'm gonna have to stop and sort out what I blame it on the cats. Oh, luckily I found the problem right away, and that is I'm guessing either I did it or somebody else did it. That was turned off. That's the problem. Okay, maybe a cat stepped on it on the way going by. I don't know. Okay, so now we're going to make sure you can see my hand here. We are going to, radio's off. Apply the power. There we go. So the power is 115 volts, but it's coming through those light bulbs. So when the radio draws power, the light bulbs will light up and a lot of the voltage will drop on those light bulbs. So the ultimate voltage getting here would be very low to start with, like 50 volts, something like that. Power off. Okay, there we go. still turned off. We're checking to make sure the off switch is off. And of course nothing happened. There is a light up here. Turn the power off. Is this light going to come on? It's much better if your radio has lights that come on, because it's much harder to forget you've got it on your bench. You're working on a radio with no sound coming out of it. I sometimes forget it's even on. That's bad. Let's check the light. Are we going to see any light from here? We are. We are going to see light. That's great. Okay, let me put it back in. Everything's an indicator. Everything becomes a test device. The Magic Eye is particularly good. The Magic Eye is connected in such a way that you can use it as a indicator, sort of a qualitative indicator if you're aligning a radio. Wouldn't recommend it, but you can do that. Okay. Okay, this time we're actually turning it on. So what can happen? So something could happen, make me turn it off immediately. And that could be anything from smoke, flames, wild sounds coming out of the speaker. None of it is expected though. What I expect will happen is the light will come on fairly bright, as I explained before. Okay, we're switching this on, and we're going to switch this on. So both lights have come on the front panel here. It's a very good sign that the transformer is not overloaded. The amount of voltage reaching the radio though is quite low. 76 volts. Now at 76 volts it takes a long time for tubes to heat up. And 76 volts is pretty low. You know what? I should be careful with bending this around here. Let's just leave it like this. I can read that. 72 volts, nothing apparently going wrong. No sound in the speaker. Volume low. Who's the volume control? Well, we're getting sound of the speaker, which is really good. Oh. Who's the volume control? These controls can be dirty inside to the point where they don't even work. And you can definitely tell there's dirt because of all the scratchy sound. But I can't detect the volume change. Well, I'm going to guess this is the volume. Why don't they guess? I could take a look and see what they've done with the wiring here. So this has a shielded wire coming up to the center terminal. This is the volume control up here, even though this guy's making lots of sound. So leave him in the middle. He's tone. Don't know what band we're on. We don't know anything. So, but I'm going to inject a signal into the antenna. Where's the antenna? Well, maybe we can tell from that if it's a broadcast band. I'm going to touch this. Well, there's no wire hooked up to it, so touching that's not going to help. So no effect at all. We're still running the radio with 71 volts. There's a good chance there's tubes that are cut off. They're in a cut off state. So we need more voltage. So what I'm going to do is, because it looks like there's nothing seriously wrong here, I'm going to get rid of the dim bulbs and let the full voltage come through. But I'm going to turn it down a little bit before I do that, so it won't be like 100 volts or so. So we're going to turn this down. I'm going to flip the switch up. And what do we get? Getting a hum. Getting a hiss like a radio there. Getting a cat running around behind me. 93 volts and it sounds like a radio. Let's go a little higher with it. Sounds more like a radio. 100 volts. Most of these radios will work with this kind of voltage. So let's leave it there. Antenna. Not happy about the antenna, but there's a there was a capacitor up here. Oh, I can't turn it. No effect. So we're not getting any effect in the output from touching the antenna. Is that because I have the volume right up too? Okay, now we're going to do the band change thing without knowing what band we're on. So there's a band indicator up here, and maybe I can figure it out. Turn this way. No, I'm not going to figure it out. I think this is just... I have to move the camera here. Don't be touching the camera and the radio at the same time, Jim. You know, this string should be around here. This is not the right time to be doing this. With the radio operating initially like this. Should be around that. Get around there. Slack that off. And this string is supposed to come up string is supposed to go over top of this thing. So I'm getting louder. Up and over. Oh my gosh, that matters. Ooh! Thumbs up on that sound. Work the band switch and hear all that crashing. That's a good sign. Now, I can read the front of it, and I see, according to that thing, we're on band 31. That's not where we want to be. We want to be... pretty hummy. Buzzy hummy. We want to be on band broadcast. Which way? Which way do we go for that? 25 meter band. 19. I went the wrong way. So that's shortwave band at the top, down, down, down. Band A. We're on band A. This is the broadcast band. So this is the one we have the best chance of hearing something. Volume up. Oh, I told you this radio's going to work. Okay, we're going to put an antenna on it. Where to ground it? Well, probably to the, I'm trying to think, chassis? What did I see on the schematic? We could just hook up one leg for now on the A2. It's supposed to be on the A2 and A1. This should really go to A2 and A1. Can we do it here? Okay. You're in the way, man. Step aside. So this is the A2. That's the A3. Where's the A1? That's the... looks like an L. What the heck is an L? Careful, 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 careful. That's a G. Well, there's broken wires there. Hook it up to anything at all. So get any signal into the radio. It may not be ideal, but it'll be something. Turn it down. No, this one here. Oh, not that one. Which one? I can't remember. This one. This is the volume. Turn it down. I remember now. Hook this up to A2, which is probably not going to work. Volume up. Leave it off. Just leave it hanging. That sounds like it's picking something up. And it will now tune the radio. How do we know the push buttons aren't active? We don't know. We don't know what's up. Tune the radio. Ho, 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 ho. She's a working. Can we get something? Lots of noise. The noise may go away if I ground it. Oh! Let's try putting this ground on. That did not help. Did it retune the radio somehow? No, it did not help. Volume, volume, which one's the volume? What if I... Well, that's good enough anyway. I mean, what am I doing? I'm not trying to make it work wonderfully right now. Yeah. Donald Trump news. Yeah, Mr. Trump's tariffs have been challenged, but not the steel and aluminum ones. Unfortunately, not all tariffs have been challenged away, but I think in the long run they will. So, this is probably 590. Can I get a look at the front here? Can I dare touch this stuff? I don't want this sitting on the cone, so I'll use this method here to look at the dial. Oh, the dials. There is no dial. There's no dial to look at, Jim. It's in the radio. There's no dial. Well, I'm pretty sure this is 590. If it's 590 and we tune further that way, I think we're going down in frequency. We should. What the static was. Are we coming to the end? But it's receiving pretty good, except for the hum. And excellent. We're going to shut it off now. Okay. Wow. Okay. That's a big step forward. What this proves is everything is essentially there in the radio. The coils are intact, which is very important. We already know all the tubes are working. That's a very good result at this point, despite the hum. And you can see all these capacitors in here. Wow, you know what the problem was with the one I took out? It was actually totally shot. You wonder what the radio would have done if this proper capacitor wasn't here. It may have just howled and screamed. Because the purpose of this capacitor, I have to look in the schematic again to be sure, but I may be wrong, but I think this is the one that's on the screen circuit, and if you take that away, you're going to get all kinds of weird feedback and weird stuff going on in the radio. Okay, that's good. I'm happy. Good job. Little pat on the back here. There's nobody here to do it, so I have to do it myself. Well, thanks a lot for watching. Tomorrow, probably what we'll do is investigate the other bands a little bit and look more closely at how this push button situation works and make sure I understand how to operate the radio properly so I don't misoperate it and then think the operation is a result of something wrong with the radio when it's just me. I don't know what I'm doing with it. Even a radio with only 4 knobs. Okay, thanks a lot for watching, and see you on the next video.